Here we are, number 4 of the Spring 2013 Exam 1. We're given information about a path that something walks, so we need to read this carefully. The people that missed this problem tried to work it with geometry and trig. We're going to draw it out, and just remember, we've talked about in class that if we're adding vectors, in this case we're walking to get back to a starting point, so these vectors need to add up to 0. If we're adding more than 3 vectors, it's virtually always easier to use components. So don't go down the path and get lost in geometry. Make a chart and work it with components like we've done many times before. So let's draw it out. That's the other place people made some mistakes on. So let's read through it. We go south, then we go west, and we go north of east. Alright, so north is up and east will be to the right. So I'm going to go south and west, so I'm going to start somewhere about right here. Try and draw it approximately to scale. It doesn't have to be exactly, but this will help you spot some mistakes. So there's 40 south. So here's my starting point. Okay, so I've got that one. And I've already see a mistake. I went 20 south. Okay, so let's go back and correct that. Actually, I'm going to correct it. I want to draw large. Maybe a little bit too large. Get this thing going. We'll go with it here. Okay, so there's 20. I'll make a little note of that. Okay, 40 west. So let's go 1, 2, 3, 4, something like that to the west. Again, it doesn't have to be exact, but a to scale thing sort of helps. Okay. 25 north of east. Okay. So we're right here. East is to the right, and so that's our reference. Let me draw it in red here. So there's east. Okay, so right about there is 25 north of east, or above east. Angles are hard to get to scale, but do the best you can. 25 is about a third of the way to 90. So we'll draw something like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So hopefully, and that was our 80, and this is our 40. So if I were to work with this in trig, and we want to find how far and what direction to go back, I would get lost real quickly. I got lots of triangles. There's tricks to make it a little bit easier, but definitely use components. Alright, so we're going to set up a table, and it's going to have 4 things. It's going to have the magnitude, direction, x, and y. For every vector, we've got 1, 2, 3, 4. Okay. So first couple are real easy. A magnitude of 20, direction of down. Alright, so we're going to use x corresponding to east, y corresponding to north to keep things straight. So this is going to be 0 in the x and minus 20 in the y. Alright, the 40 magnitude is going to the left. It's going to be minus 40 in the x, 0 in the y. That's why it's important to draw the arrows on your vectors, so you make sure you get the directions correct. Okay, this third one, know its magnitude. We know it's at an angle of 25. Alright, we're going to need to do components. Anytime it's off of horizontal, you're going to use cosine. You're going to use a hypotenuse. Okay, it's the adjacent side to the 25-degree angle, and it's going to the right, so that's positive. Our y is similar, it's going up, it's adjacent, and there's our angle. Almost done. The red vector, we do not know its magnitude, we do not know its angle, we can write unknowns, or just use variables for x and y. That's the key. Two-dimensional problem, we can have two unknowns. In this case, the unknowns are the x and y. Okay, if we know the x and y of this vector, we can calculate its magnitude and direction. So those aren't really unknowns, they're dependent upon x and y. I could have written this as magnitude cosine theta and magnitude sine theta. My two angles or two unknowns would be the magnitude and the angle, but x and y are just components that are a little bit easier to work with. Alright, so moving on, this is a test. So we need to work quickly. In the x direction, we still need to show our work. We're going to have 0 minus 40 plus 80 cosine 25 plus x equals 0. Start and end at the same place. Okay, if you wrote this equation right here and the corresponding equation in y, minus 20 plus 80 sine 25 plus y equals 0. If you wrote those two equations, you got most credit for this problem. Okay, but we still have to work it out. So let's get our calculator going again here. Alright, so this one's not going to be too bad. Clear things out. Let's go minus 40 plus, let's see, I need to solve for x here, so I'm going to move everything over to the other side. So it's going to be positive 40 minus 80 cosine 25. So let's do this again. Positive 40, just switching the signs. If you want to write this step out, you can, but you don't have to write out all the math steps. Okay, so x is going to be minus 32.5. We're in units of meters. Y, we're going to do similar here. Let's see, y minus, oops, we're going to switch signs again just like we did before. So 20 minus 80 sine 25. I'm doing the calculator just to not skip steps and have a good reference for the length of these various problems. So there's my x and y, and that looks close to what I expected. Drawing it to scale, we're going to the left in x and we're going down a little bit in y, so that looks reasonable. Okay, so the distance is just the square root of the sum of the squares of those two numbers. Don't make the mistake of forgetting to square the negative sign. So if I were going to write the negative sign, I'll put it in brackets in there. So for completeness, I'll do that. Okay. Alright, so the y was my answer, so I can square that. And then I'll add in the x value. Just type that in. Something like that. Square it. Get that answer. Whoops. Okay, so I did that very same. I get a negative number here. Wasn't very careful with my parentheses in here. Let's back up and do this again. When I see this, I just always use the positive value, and I'll go ahead and put the square root on the front. You could do it after the fact, either one. 32.5 squared plus 13.8 squared. Alright, 35.3. Remember, the hypotenuse always has to be bigger than either one of the legs of the right triangle. 35.3. Okay, we're almost done. So we know the length of this is 35.3. We need to find its direction. So I would think of this angle right here. go ahead and label that on your drawing. That way when you write tangent of theta, we know what you're doing. It's going to be the y component, and I'm going to use the absolute value of that, 13.8, over the opposite over the adjacent, which was our 32.5. Alright, hopefully I've done that right. Let's see. So I want to take the inverse tangent, 13.8 divided by 32.5. 23 degrees. Alright. So we need to read another somewhat common mistake is only giving half the information. We need to give an angle, we need to give a reference, and we need to give a distance. So we've got a distance of 35.3, let's see, units of meters, and our angle is going to be off of west, and it's going to be south of that. Okay, so we can say 23 degrees south of west. If you had given this angle, you would have had, I guess it would be about 67 degrees. That's going to be west of south. That's a perfectly valid answer as well. Normally when you're using compass directions, you keep them less than 90. Okay, we also accepted the counterclockwise from east or counterclockwise from X angle. That was what, 180 plus 23 or 203 degrees. That was one of the longer problems on this test, but again, if you work it in components, it's just a several steps, getting the X and Y and then resolving that back to a magnitude and direction.